Hi there, my name's Sean Farmar and I'm a solution architect, in particular software. I've been doing service-oriented architecture, what's now called microservices, distributed systems, and NServiceBus for the last kind of 10 years, roughly 2007-8. I started doing that. Today, in the last 4 years, I've worked for a particular software, and I'm working with customers around training, consulting, and supporting them building distributed systems. I see that there's a St. Patrick's celebrations even here in Vienna. I'm from Ireland. I'm originally from Israel. I moved to Ireland 13 years ago. My wife's Irish. My parents are Irish. So I feel very proud to have seen this kind of celebration even here, the other side of the world. Any Irish here? No. I'm just chancing my arm. Yeah. So today's talk is more about trying to teach or kind of show what we learned with service-oriented architecture, all our failures, and how hard it was to get to a point where we were able to successfully build distributed systems and get a really good design in place. And now we have this kind of new fad, which is the microservices, and it's catching up like fire, isn't it? Anybody here do microservices? Yeah, a good portion of you guys doing microservices. So everybody's on the bandwagon. And the only troubling thing I see with microservices is that we've done the whole SOA or distributed systems for many years now, and the whole microservices movement seems to forget everything we learned. It's very common in software development in our business that we just seem to forget what other people have already learned and forgot to forget. And so I'm hoping that the little you get out of this talk is just to avoid those horrible pitfalls and those struggles that I went through until I was able to build a good system. And don't get me wrong, I love the microservices idea. I have nothing against, I'm not preaching against microservices or anything like that, but I think that they could be done better if we learn from past mistakes. So I've started doing this SOA thing quite some time, about 10 years ago, but I've been developing for 20 odd years now, 23 or something like that. And before I came to SOA, I started as probably most of you have, building those business systems, whether it's e-commerce or internal business systems. You come into a new project or a failing project, one of the two. It's always one of those kind of things. And if you're really lucky, you get the opportunity to build a greenfield project. And I kind of learned the business and then go about, pick up my Tiger team or be part of the Tiger team and build this, all new, shiny, clean, well-designed, well-thought-out architecture that's going to last forever, right? And I built, using all the best practices that Microsoft and others have provided. We put it into production. Everything's really great, yeah? Tiger team moves on 3 months later, 6 months later. The business succeeds, or the application is successful. The business grows. There is something, some feature requests, some changes, and either the Tiger team or the next team after that, the maintenance team, poor little buggers, are there, to pick up the slack and start modifying your beautiful design. And a year and a half later, you find a huge big ball of mud that totally doesn't resemble your beautiful design. It's just gone out the window. And although all the best practices were adhered to, we come into this point where we get loads of performance issues, we get bottlenecks, the nightly jobs run over the 24-hour segment. Like we can't find a time to run the bad jobs because there's just no more scale to do. Everything is really, really hard to change. Anything, any pull request that comes in from the business, all of a sudden, all developers disappear, right? They're really busy doing this other thing. I just have this bug to fix over there. I'm sick. I don't know. I'm not going to touch this code. You just look at the code and start vomiting, right? You just go like, and the business also gets into this very edgy, nervous thing. Yeah, they go, if we do another change request now, we're going to suffer. It's going to cost us. All the development team is going to go into crisis mode. We're going to deploy it into production and fix it and stabilize it and fix it and stabilize it. And then 6 months later, it's going to be all right. Yeah, we've done our fixes, and then we go through that cycle again and again and again. Anybody been there? Is it far away? Yeah, we all been there. This is what I've been experiencing, and I've been doing this for many times. It's not one time. You say, oh, I did this couple of stupid mistakes in this project. I won't make it again in the next project, right? I've done it a couple of times, and in big, small and big projects, and I felt, I'm going mad, right? I'm doing everything right. I'm trying to do my best, and I'm failing constantly. Now, of course, it runs, it's in production, but it's a failure, yeah, at the end of the day. And Einstein said, somebody who tries to do something again and again and expects different results, what is he? He's an idiot or he's crazy, right? One of the two. And I felt I felt both, yeah. So my last attempt actually reminds me very much of what microservices are doing today, and that is like I took a whole architecture and split it to multiple multiple applications communicating with each other, multiple monoliths communicating with each other over web services. Anybody tried that? You successful? Yeah? Okay. It's very interesting because that's very close to the kind of microservices paradigm. I did that and I failed miserably. Even like things were even worse than what I thought they were with the monolith. Because in the monolith it was like, oh yeah, I have a bug. I go fix that bug. That's done, right? It's like I can kind of cope with that. When the application fails again or the system fails again, I can look at it and say, oh yeah, that's this component on this server in this module. I just need to fix that thing. I do a quick patch, everything's fine, right? But with 5 applications talking to each other with web services, when things started going south, it was, you never knew where it started, who is the cause, and it was a self-denial attack, yeah? Like my own application was denying its own service, because once one component failed, it started, being slow or just failing. Then the calling service was also failing. Then the thing that called the calling service was also failing. And, slowly, we saw everything just collapse. And now you had to figure out in the distributed system what's going on, right? Where is the problem, right? So I was really, really frustrated. And really, I was actually thinking of just, maybe call it a day. Let's go back. I was sound engineer for 12 years. Let's do sound engineering. It's much nicer. So I went to my master and I said, Master, what is going on? I'm doing everything right. I'm trying to do everything right. We're using all the new frameworks and all the new features and all the new ideas and paradigms and best practices. Horrible word, best practice. And I'm failing. So in Yoda voice, he said, solve the problem you want, coupling your problem is. Now, that makes a lot of sense, right? Coupling is what kind of every time we try to touch something and everything else breaks, that is because everything's coupled to each other, right? There's dependencies, there's things calling each other, components calling each other, and if something changes over there, the other thing will be affected. And when we try and separate stuff, then we get to this point where we go, oh, if I'm taking this little component or module and trying to put it over there, I'm going to pull all this other shite with me, right? It's all going to come with me. So where do I start cutting? And if I start cutting and botching, I find that I have huge dependencies between these different components, and I end up with this big ball of mud in small bits, and that really doesn't help. So I said, that's great. Let's just decouple all things, right? So just go like, just throw everything away and start cutting, and it really didn't work. Every time I tried to pull something out and make it loosely coupled or autonomous in any way, I felt that I'm pulling a lot of stuff together. I'm pulling loads of things that were already well, kind of encapsulated and all that. Now, when I try and pull them out, they break other things. It was really, really hard to kind of find a way around it. So let's look at coupling, and just to try and understand what coupling actually is. So there are about 5 or 6 dimensions of coupling that we can look at. Afferent and afferent, I never get it right. So afferent is the stuff that depends on you. Anything that kind of is using you as a resource or calling you to get something or calling you to do something, they depend on you, because without, if you go down, if there's a bug in your code, in your component, then you break them. And afferent is what depends on you, stuff that that you need in order to complete your functions. Could be third parties, could be just another component you're calling to complete some work. The other dimensions that we need to look at, by the way, over here there's no magic number, yeah? There's no zero coupling ever. You're never going to get to a point where, if there's zero coupling, you're building an application, like Word, Excel. You're not building a system, right? If you're looking in, to a magic number, 2 and 5, 5 and 5, 3 and 2, there is no magic number. The point is to get, to as loose coupled as possible, right? If we're looking at other dimensions that are very clear to us, we look at temporal, time-based stuff. Spatial, which is like space where things are located, which servers are in which zones on the network and so on, and platform. So in temporal, and if you take anything from this talk, take the temporal coupling, okay? Temporal coupling is classic, yeah? This is, anybody doesn't use Facebook here? Doesn't. All of you don't do Facebook. Don't do Facebook. Somebody? We all do Facebook, right? And when we want to, when we become friends with somebody, then we are time bound to their actions, right? Every time they do something, we get a notification that they've done something, right? So time-based coupling is something that is related to how long does it take for the other party to acknowledge or reply to your request. So every time you call a web service, the time that it takes for that component to reply, that would be your coupling time. Okay, even if it's a logical one, yeah. So even if you make that call asynchronously, and you're now bound, you're now sitting there, you are unable to do other work while you're waiting for the reply or for the response from that component, that is your time bound. You're bound to that other component. Synchronous communication is like, I need to get some data from the database, I need to get the data from a web service, from a third party. Anything that's IO bound and not CPU bound or memory bound is something that will take time, something that is gonna make our coupling greater. And in addition to that, every time we start a synchronous communication, that thread is going to sit there and wait for the response. Okay? So if the other component is down, we either explode or we just sit there and wait for this thing to reply. Okay? The logical temporal coupling is all about what I said earlier. If you're just sitting there and waiting and not able to respond to your initial request because you're waiting for this other thing to come back. So even if it's structurally or technically sound, you're not getting a reply and you're okay with it, you're not explode, you don't throw an exception or your thread goes down, you're still sitting there waiting to complete your job. We'll talk about that a little bit later. Special is more about physical. Where do we put stuff? Where's the endpoint, the endpoint address or SQL, where is SQL Server? Anybody still doing or done before this, put my SQL string, connection string inside the code? We do that today? Anybody? No, we're all angels, aren't we? Saints. So I did it when I started coding. That was very common. It was smaller things, and we did it. And then I learned that it's really, really bad. So special is all about where you deploy your thing on the network, how close it is to the network. That kind of it would change your performance. It will change if the admin decides to move your SQL Server from one IP address to another, and you've used an IP address, then you're basically lost your database right now. And platform is all about protocols and platform-specific features. Anybody did not .NET remoting here? For example, no. You're all Java people, aren't you? Yeah. So Java-specific stuff is like, what do you call DTC in Java? Distributed transaction management in Java? No. Okay. So that's the kind of stuff, yeah? Stuff that you can't use Java and .NET together to do the same kind of operation. You're going to be calling using a specific protocol. It has to be Windows to Windows, Java to Java, but they can't mix. So all these things that have to do with coupling, when you go to distribute stuff, even if you have a monolith and you're communicating with third party, this is already like kind of distributed systems, right? The beginning of that. How many of you do this? Nobody calls service here? Not using third parties to do your payments, yeah. Sorry? You don't do this anymore. You do dependency injection, right? That's even, yeah. So when we do this thing, our expectation here is that the result is going to give us some data, right? The best case scenario is we couple that, we put that around, we put a try catch around that. Yeah? Agreed? Fine to do try catch here? What happens when the catch happens? When an exception is thrown and what do we do when we do the catch thing? Yeah? It depends, yeah? We log it, yeah? Okay. So usually we log that there was an exception, or we bubble up the exception to an exception manager or something. But the data, the stuff that we just passed to invoke the service with, is all gone, right? Anybody tried here to save the data before they call the web service? Yeah? 1 or 2, it's very good. But for most cases, we assume that the service is there. When you write the code, the service is there. We don't think that the service is going to fail, right? And that's why we're going to talk about the fallacies of distributed computing. Those fallacies are very, very old. Yeah, they're like, I think they come back from '94 or something like that. And it's written by Gosling, James Gosling, and a couple of guys from Sun Microsystems. Back in the day when Sun Microsystems were not doing Java so much, they were doing networks. They were building network stuff. And he came up with those couple of fallacies of this that he kind of identified that we as developers and architects look at approach our design and ignore all those fallacies. Yeah, we act as if those fallacies are true. Network is reliable. Can ask Amazon and Google about that one. Latency is 0. The bandwidth is infinite. Yeah, there's no problem. Just more and more data over the network. The network is secure, of course. Topology doesn't change. There's only one administrator, so when the administrator is gone, then nothing's going to work. Of course, the administrator is always there. We never think about the risk of the administrator winning the lottery or something else. Transport cost is 0, and the network is homogeneous. And all these, if you look at all these fallacies, and go back to your code or your architecture and look at it, you'll see that those assumptions are valid. We never look, at how much data we pick up or what happens when the network's down. We don't mitigate for network outages. We just go try catch, and if it's not there, the client will try again. I don't care. If it's $1 million order and it just went, that's fine. That's cool. There's no problem with that, right? I'm not diving deep into those topics because I'll give you this link here, and you can download an ebook that has the whole story, really nice, well written, and it has the whole stories, the mitigations, and a lot more details and depth. Also look at Ted Nude's blog about the fallacies, which is really, really nice, a really good blog. I'll let you take another picture at the end. So, why did we start off building microservices? Microservices started kind of 5 years ago, roughly, and it started because people were tired of having the monolith break on them. The scale thing, you remember the MongoDB scale thing that ran in the internet for ages? Yeah? No? Anyway, the scale thing came in, and everybody was trying to be scaleful, to get scale, to be able to operate at scale, to build big systems with loads of data and loads of customers, and be highly available and all that. And that was really, really hard. The giants were running that okay. Google and Amazon. They had different approaches all around, but nobody on a small scale was able to actually to access. It was too much overhead to build, to emulate this kind of architecture. So microservices came along and said, it's not a problem. Just build those little, break down the monolith and build little islands of functionality and expose them and deploy them, and then run your business on top of that, and everything's going to be cool. In the regular monolith design or architecture, of course, this is a very lightweight representation of an N-tier design of a monolith. This is the kind of thing that we have. We have like a UI, a business layer, database access layer, and then a database beyond that everybody talks to. Everything is singular. Yeah, we have one database, one layer for that, one layer for that, one layer for the other. Of course, on the side here, you'd see all kind of common services, common frameworks, and between those layers, you might have layers and of all kind of service layers that make it look really cool, right? But at the end of the day, all this is like tightly coupled on the horizontal. Yeah, so the UI would be very coupled along along the layers, and so on and so forth, and very loosely coupled on the vertical axle. Yeah, so it's going to be little. There's going to be little communication between those layers, at least by design, right? When we start building the system and then maintaining it, which is more important, then people start, how can we say it, bypass the design. Yeah, they bypass the layers, because it's all of a sudden really hard to talk from the UI to the business layer to the DAL to the database. Why not just put some business logic in the UI? That's so simple, right? We have all these magic frameworks that build all these things on the UI. So some leakage go from the business logic up to the UI. Or the other way around. Why do we need the UI at all? Let's just do all the business logic in the database. Store procedures, yeah? Bad jobs, all the lovely things that SQL can do, and absolutely it can do it, could do it very well, but still, you put it in a database, it's hidden away from everyone, and once you try to change that behavior, God help you. And so basically, as we go from V1 to V2 to V3 or 1.1, 1.4, 1.5, we end up with this thing. This big ball of mud where everything talks to everything. There's no clear understanding of what is there. And usually the maintenance developers that come along after the first nice versions will actually bypass the whole thing, right? Have you done this before? You looked at the thousands of lines of code and go, nah, I'm not going to do that. I'm going to take this new bit of functionality I need to do, just write a little class over there that's going to bypass this whole mess, and I'm going to do it my way. And I'm going to jump from, directly from the UI to the database, which is, I've seen nothing wrong with that, but just the side effects from doing those kind of patches are interesting. So instead, and this is very much part of what the kind of the microservices and SOA, that's where they share the paradigm, is that when we go to build scale stuff, instead of having tight coupling here, we have tight coupling on the vertical, and we reduce the width or reduce the amount of stuff that's being done on the vertical slice in order to make it really easy, or much easier to achieve loose coupling. And of course, when you look at the different kind of components, and each component is isolated, it goes and provides all the functionality top to bottom, and mind the gap. Yeah, make sure when you look at those kind of systems, never forget the database. Any resource whatsoever should not be shared. Yeah, but the database around reads is okay to share, maybe depending on where your data is and how you build your architecture, but the writes should not be shared at all, right? And if you take the second point to take from this presentation is, do not share your data, yeah? And doesn't mean, read is all right. Read it's a totally different thing. Writes are what's important. There should be only one owner of this piece of data in the whole app. In the whole system. And the reason for that is that if we start sharing the data, what are we doing? We're reintroducing coupling, right? We're saying like, oh yeah, actually, when I need the CRM needs to do an invoice, I'm actually gonna update the customer record to say that I sent him an invoice, right? So why should I send send a message over to the customer service to let it know that no, I'll just update the data directly, right? That's where the fun starts, yeah? So when you do vertical slicing, remember to never, ever share your data. When you want to do reads, you can do publish reads, you can do caching, all kind of funky stuff, have an AI, whatever, to build, business logic, to build some, reporting model, something that allows other people to share the data in order for them to read it. But don't ever share your write data. So when we look at the definition of service-oriented architecture, and I don't think it's that far away from microservices, is that we're trying to address the coupling in a software design by building loosely coupled, highly encapsulated components. And Udi Dahan I'm quoting Udi Dahan here. It's not my, anybody know Udi Dahan? Heard about him? A couple of you. Look him up, he's interesting. The point is about loosely coupled and highly encapsulated components. And highly encapsulated components is very much like coming from the object-oriented kind of methodology or paradigm, yeah? So in object orientation, we say that we want to encapsulate our business logic and we want to hide our behaviors and not be, and only enable the outside world to use it without knowing what we are actually doing inside. Yeah, we keep it encapsulated. We do whatever we want to do inside our component and not allow anyone else to change our behavior or forcibly cause us to do something we don't want to do. Okay, does that make sense? And we create autonomy here. Okay. So encapsulation is all about autonomy, is about I run in my own context. I can do all my stuff by myself. I don't need anyone around me. I'm not dependent on anyone else to do my business, what the function of my business, okay? As we go around to achieve autonomy, we need to decompose our business entities into kind of components that are they are a definition of what we do. Those components are, as we decompose them, they can provide business value. They can do something that we can explicitly say, this is what this component is doing. It's not doing anything else. It's doing this very well-defined business ability or business capability. And the important thing here is that when we come to decompose this thing, we walk away from the monolith, well-designed database, the database concept where everything is linked to everything, yeah? Where we go and build like this huge SQL tables with referential integrity that, everything is linked to everything. So we have a user and the user has, a link or a reference to orders, and orders have a reference to items, and items have reference to products, and so on and so forth, and all this kind of beautiful schema that looks really well to try and explain something to a business person. That's great. In the real life, if we introduce those huge entities and try to get them to work together, then we come back to problem number one, coupling. Because if one field in my database, in my table, changes, then that means that I need to update some other table, right? And that means that everything is kind of coupled. Everything depends on something else. And if it's a big table, a big user table, for example, or a big product table, or a big any table that has multiple fields and different fields interact with different components, with different business concerns, that means that we are back in square one. We're back to having a table that like a coupling between our data in our data resource, which means that we can't do an operation without affecting other components. Okay, so instead of looking at it in the beautiful schema of having loads of dependencies between different tables, we carve out the tables, the properties that interact with each other, put them into a single bounded context, carving out the single bounded context and putting them into a single table, right? And that single table then would belong to a single component. Does that make sense? And then when we interact, no other component is trying to access that data. That data is mine. I am the owner of that data as that component, so I can encapsulate my data and my logic from other components and do my own thing without having any effects from other components. Does that make sense? And bounded context, inside the bounded context, you can have high coupling. There is nothing, stopping you from having, inside the thing that you're doing, all this business activity that you're doing, if there is high, you're expecting it to have high coupling because you're expecting all these things to happen in one logical transaction. Okay, it doesn't have to be physical, doesn't have to be ACID in that way, but it has to be this. This component does everything in kind of one go, if you wish. Yeah. So if I want to create an order, I need to do three things. Maybe those three things might be a bounded context because if I don't do those three things together, that doesn't really work, right? I can't say that I successfully created an order or created a user or created an account. Okay. What that leads to is having a very, very, very fragmented database, right? Very, very fragmented components, a very fragmented design. You're going to end up with loads of little things all around you. From a design perspective, it's another thing that we all do probably very well, but we generalize stuff all the time. That's how we taught to build, right? If we have a method that, the CRUD operation kind of thing, yeah? CRUD? Do you do CRUD? Yeah? CRUD is the most generic thing you can do, right? What does it do? It says, create me something, this entity, update me something, delete me something, and read me something, right? It is totally generic. There's no business activity there. There's nothing that describes what you're actually trying to do. The example I could take is like update user. Does anybody know what an update user do? Anybody here has an update user and knows what it's doing? It is physically can update some fields in an entity, right? What do you do when you want to try and figure out what happened? What do you need to do? You look at the source code, you try and investigate the data, right? What came in, what field changed in this update, right? Yeah, and then you go, oh, actually this phone number, this update just changed the phone number. All right, now I have to do if else, cases, factories, whatever, to kind of go, oh, this is the event that I want to raise. I want to raise a phone number changed event, right? I want to say, oh, this is what actually happened. Can you imagine how when you have a rich business entity like a user and you're going like, oh, I'm going to have like this method that's going to do, of course it's going to be injected and it's going to have factories and all that. It's not going to look that dirty. But effectively every time an update comes in, I'm going to figure out what I need to do, right? Because otherwise it's just an update and it means nothing. It has no merit and it could be any of the 20 fields that you have in this table. So instead of generalizing, take the pain and go create a method and a DTO or DT, whatever DAL or however you're going to get this into the database. that does only one thing. If I want to change a mobile phone, I'm going to say, change user mobile phone and be explicit about it. Name the method correctly, pass very little arguments, and pass in the data that you need to, again, a small amount of data to make that operation explicit. When your coder, another coder looks at the code, there's no arguments here. You're updating the user's mobile number. If you want to raise an event, then to say, oh, I have some, other bits of the system want to know that I've changed the user's bank account or the user's mobile number, you raise an event, and the other components will know what to do, because it's very simple for them to know that the event is not update user, it is I've just changed the mobile phone for that user, or I've changed the bank account. Coming out of that again is SRP. So anybody does single responsibility here? Can you vouch for that? Shall I look at your code? It's really, really important to stick to that thing where you go, I'm doing one thing in this method, and then I'm passing the responsibility, not calling another method to do another thing and calling another method to do another thing and calling, but just go, I'm doing this, I'm done. When I'm done, I'm going to raise an event, send a message over there. But when I'm done, I'm done. I'm not doing other things. Also, when you come to maintain those simple, small, explicit single responsibility items, it is easy to get this across, to fix it, or to create a new behavior. Another one is that when you have smaller items, smaller things, it's much easier to fix them. It's much easier to know how much side effects you're going to get from those small things, okay? And keep your verticals thin, top to bottom, is all about don't start at the top with very small thing, and as you go down the chain, start expanding your, the first thing is just update mobile phone, then you're going to call another method that's going to create mobile phone and add some logic to what happens when that, and then another one that does another bit of logic, but it's much more stuff, and at the bottom you're going to update a huge table that's going to do all kind of funky stuff. Yeah, so keep your slices vertical all the way. Don't let them grow arms and legs, and don't pull the kitchen sink with you. So lessons learned from what we did is, first, it's hard. It's a lot harder. The productive side of it, when you start doing distributed systems or microservices, SOA, it is much harder. Yeah, it's much harder to get started and to get like the infrastructure right, the design right. To get, this is a much bigger learning curve. However, as opposed to what happens in a monolith, you plateau at some stage. Yeah, you get to this point where you have a good design, and then you can plateau. The maintenance, the extensions, all that is, the effort is relatively stays the same. One of the biggest things that I want you to, the third thing that I want you to remember here, is that you should use asynchronous, non-synchronous communication between your different components. Okay, so I see a lot of people doing microservices with RESTful interfaces. Yeah, and we have like this microservice calling this other microservice. In order for it to do its job, it needs the other microservice data. It sounds really logical, it sounds okay, but that comes back to that distributed web service thing that I failed with. Once you introduce synchronous communication, it means that this other component, you're depending on it, right? That means there's leakage in how you split your domain or your business components. So that dependency, that synchronous communication is going to kill you someday, maybe not today. It's going to kill you. It means that you're depending on another thing, and that kind of goes against the whole idea of microservices, right? It's the whole idea of breaking them apart, making them small units of autonomous work, so we can build a reliable system that is not, and change those little components without having side effects on the rest of the system, that, if you use synchronous communication, you just killed everything. It doesn't matter how it's nice and cool and has all the fancy frameworks and all that. And if it's in containers and not containers, and, just don't. So use queuing systems, whatever they are. If you're, if you have a JMS or a Rabbit or whatever you're using, use durable queuing mechanisms. They will, that kind of communication allows you to very nicely maintain durability and continue to function when the other component, whatever it is dead, right? And it will die. And when you have 150, 200 microservices or 300 or 800, they will fail. One of them will fail. Some the network's going to go down, a segment of the network will go down, something's going to happen, and you're not going to have the communication to do the synchronous communication. When you want to communicate between bounded contexts or between components that are between autonomous components, use events, use PubSub, publish subscribe. Heard about the PubSub, publish subscribe? Yeah. Very easy, nice. It enables you to go around not worrying about what you're going to do. You raise an event, the other systems will do their job based on the event that you propagated. And another point, coming back to a point I raised before, is use CQS, command query separation. Anybody heard about CQS? Not CQRS, CQS, yeah? It's very old. It's not a new concept at all. The idea is that you separate the change stating operations from the read operations. And change stating operations do not return data, okay? They just go 200. They just go, I got it. You're not waiting to get data. You send the command does its thing. Again, asynchronous, that's great. You could just send a command over there, make sure, all you need to make sure is that the communication, that part, saving that message onto the queue was successful, you're done. The read operations could be anywhere, right? You could do caching, you could do a lot of technical solutions to get reads from anywhere. Yes, there's the whole thing of eventual consistency and all that. I'm not going to get into that, but it is doable. There is ways around it. It's very important to kind of get, we usually, we get a hammer and everything is a nail around us, right? Once we have this new shiny framework or this new shiny system, we just go around saying, oh yeah, that, we can hit that with that, we can hit that nail with that, we can finish that, we can do that. And we try to do everything, NoSQL, so everything's NoSQL, messaging, so everything's messaging. If you do messaging for request response, you're screwed, right? So if you need to call a web service and get an immediate response and it's all RPC, it's all like synchronous communication, don't put messaging in the middle. That doesn't make sense, right? But it makes sense. Where it makes sense, use messaging. Where it doesn't make sense, use your RPC. But know the risks, understand remember the fallacies. Decomposing your business entities is the hardest thing ever. Every time you think you got it right, somebody comes from the business and says, but I want to do this like that. And you go, oh man, where do I find the boundaries of my data? Where is the bounded context? How do I keep this bounded context? It is hard. And, as I said before, no frameworks or tools will automatically, fix your problem. It's not about technology. It's not about technical solutions. It's about understanding your business and putting the business first and making sure that the business functions and that you look at the business as what it is and kind of decompose the domain accordingly. So I said that data right and ownerships. Referential integrity in GUIDs, again, if you're using referential integrity and you're putting microservices on top of it, you're just killing yourself, yeah? And data reads and eventual consistency is a whole topic. Monitoring, remember, if you're distributing, monitoring is your friend. Without monitoring, you're driving in the dark without the lights on, yeah? You're just driving 100 miles an hour with the lights off, and you're thinking that you're not going to hit a wall, right? Very optimistic. Testing is extremely hard, and when it comes to deployment, and you probably know all about that, automate everything. So everything should be automated from day one. The more you automate, the less issues you have in building stuff later. The easier it is to scale, the easier it is to scale out, and there's a less human factor in there. Don't forget your organization. You know, I know you're a great developer or architect. If you can't sell it to the organization, if you can't work with the teams to sell the paradigm, you're gonna fail badly. Be pragmatic. Don't always go and do a whole thing, system architecture thing, when you only need to solve a little problem over there. But keep the paradigm. Make sure that you remember why you're doing distribution in the first place, and build your business and not systems. A lot of us really love to build this, beautiful architecture system thing, and we forget all about the business. And then, at the end of the day, the businesses are paying our bills. They're why we exist. That's why we do one of the nicest jobs in the world that I know, anyway. So I'm hoping that I'm kind of running out of time, I think, roughly. So this is my kind of summary. If you're on the .NET platform, check out NServiceBus. And we don't have time for Q&A, but please come. I'll be outside if you have any questions, any arguments. I'd be very happy to chat. Thank you.